Now we're given a problem here to find the height of the flagpole from point B all the way to the ground. The observer here, however, set up their measuring equipment 2 meters from the ground at a distance of 12 meters from the flagpole. And what they found is when they set the measuring instrument at a degree of 40.8 degrees, they could just see the top of the flagpole. To try and find the distance from the ground to the top of the flagpole, we'll have to do in 2 steps. First of all, we will find what the distance is from here to here, because this forms a right angle triangle here, and then we can just add 2 meters here. So we have 40.8 degrees, that's what we know here for A, our angle. C here we have is a 90 degree. Our B side here, which is opposite of A, is 12 meters in size. So these are the 3 things that we know. Now what we want to find is this A side, or in this case they've labeled it X, which is what we need to find. But we know that the tan of A here, which is our 40.8, is equal to X, which is this, over our 12 meters. So if we rewrite this, we can say X is equal to 12 times the tan of A, which is 40.8. So let's do that calculation. Let's put in 40.8, and let's take the tan of that, and let's multiply that by 12. And we get that this number here is the distance from here to here. So that's roughly 10.4. But then what we have to do is add the 2 meters here and come up with 12.4 here. So the distance from here to here is 10.4 plus the 2 meters gives us 12.4 total distance from the ground to the top of the flagpole. However, if our observer had been able to set their measuring equipment right on the ground, what distance from the flagpole would that have been set at to give us the same reading of 40.8? So again, the tan of 40.8 would be this entire height here, which would be 12.4 over the distance that we want to find here, which would be greater than 12 meters. So let's see how we would go about figuring that out. Here, if we measure the tan of the angle, that would be equal to this distance here, which we know, times this distance, which we don't. So to rewrite this equation, we would have that the distance we're looking for is going to be this side over the tan of A. So this side we know is 12.4, and then we're going to divide it by the tan of A. So let's do the tan of A first, which is 40.8. And then let's take the reciprocal of that and multiply it by our distance here, which we know is 12.4. And what we get is this distance here. In other words, the distance won't be 12, it'll be bigger. It'll be actually 14.37 approximately. Now let's put that into memory. And let's just see, because if that's true, if this is 12.4 from here to here, and this is 14.36, then 12.4 over 14.36, if we take the inverse tan of that, we should still get 40.8 as a check. So let's clear this. So 12.4 divided by memory recall equals, and let's do the inverse tan, and again we see that it's 40.8. Typically, right angle triangle problems are set up where the observer has a horizontal, and based on the horizontal they're going to take a measurement that is an angle of elevation, such as what we have here, or they're going to again have a horizontal where they have an angle of depression, as we're going to see in the next problem. Now in the case that we have here, we have a plane flying horizontally above the ground, and it takes a reading to the edge of the lake at an angle of depression, because it's below the horizontal, of 18.6 degrees. Now what this problem is asking is at this particular point in time, when it's 1,050 meters above this point on the ground, what is the distance on this point of the ground to the edge of the lake? Now some of the things you'll notice that if this is 18.6 and this is 90 degrees, 90 minus 18.6 is 71.4 degrees, which is this angle. But we also know that this has to be a right angle here. So when you do the math, 90 minus 71.4 again is 18.6. So this angle becomes the same as this. And this is the theory of parallel lines. If you have parallel lines and a line here, then this angle is equal to this angle. Now we want to find the length here, x, which is the distance right below the plane to the edge of the lake. And if you take a look at it here, we've got tan of A is really opposite over adjacent. So if we do that math, we can say that tan of A is 1050 over x. So therefore x is equal to 1050 over the tan of 18.6. So let's put in 18.6. Let's take a look at the tan of that, and then we'll have to do the inverse to move it up top, and then multiply this by 1050, and the answer we get here is 3120 meters. So the distance from here to here is 3,120 meters. In this problem, a very large frame is braced by wires AC and BD. So there's AC there and BD here. And the distance that CD is here, CD is 5.4 meters, and AB as well. And what we want to do is in this triangle ACD, what we want to do is find the length AC, because AC is the length of one of the wires and BD is the length of the other wire. I think you see these are exactly the same length, so if we figure out what AC is, we'll also know what the length BD is as well. In this case, the sine of 31.6 is going to be 5.4 over the length AC. And so if we want the length AC, we can take AC to the other side, and AC is going to be 5.4 over the sine of 31.6. So if we punch in 31.6, take the sine of that, and then we have to put it up top, so that's 1 over, and then multiply that by 5.40, then we're going to get the length is 10.31 roughly here. This length here is 10.31. This length is 10.31. So this is a very large frame.